Well, happy Wednesday, geometry students. I'm sorry I'm not with you today, but I thought I would video some notes so that you could get a start and try to start to understand what we're doing now. We're introducing some proofs early on in the year, and we're going to start with some algebra, your favorite. So you have several things going to be handed out to you today, if they haven't been already. You have a blue packet, and this is what it looks like. It's got a 3.1 and then it's got some blackout because we wanted to rename it. These are your notes. Post notes at the top there. Okay? They have examples. We'll go through them. We'll fill in the steps. Okay? These are all your notes. It's a good packet of information. Stick it in your 3-ring binder. Then you have a yellow packet. It's also got 3.1 at the top and then some blacked out. The yellow, this is your homework. So when I post on the assignment sheet 3.1 pages 25 and 26 for your homework, this is what I'm talking about. Okay? Yellow, homework. The other thing you should receive is a 1-page blue sheet that looks kind of like this. Mine's white, but yours is blue. And what I did was I just took those algebraic properties that are on the blue sheet, this small table, and I blew it up a little bit right here. Okay, these are all properties that you should have heard of kind of before. We did go over these last year in algebra for those of you guys that had algebra with me last year. Mr. Gorman did them as well, but we went over them pretty fast. So I've listed them again. We have the addition property of equality, subtraction, multiplication, division. The distributive property just says when you have a number on the outside, you've got to multiply it by everything on the inside of a parenthesis. And it can look like any of these 4 situations. Substitution. This is where if you have 2 things equivalent to one another, you can replace them in any equation or expression with their equivalent. Substitution. And then you have some of these properties that you may not have seen before. Reflexive. This is like your reflection in the mirror. For any real number, A is equal to A. This will make a lot more sense when we start with geometric proofs. You don't need to know it as heavily right this second, but you need to know reflexive property. The symmetric property just flip-flops the 2. If A is equal to B, then B must also be equal to A. The transitive property of equality is very similar to the law of syllogism that we just got done studying. If A is equal to B and B is equal to C, then A must be equal to C. Now what we're going to do is we're going to take these properties and justify the steps of our algebra. So this is going to be a great algebra refresher. Or it might be just a great algebra lesson for those of you who just can't remember your algebra. All right, so in a proof, we are given some information to start with, and then we are asked to prove a statement. A lot of times we use conditional statements where the if part, or the hypothesis, is the given information. The then part, or the conclusion, is our prove statement. So you might see it written like that as well. All right, so we're given 3x plus 12 is equal to 8x minus 18, and we want to prove that x is equal to 6. So this is just solving equations, and now we're justifying our solution in each step. So here are our statements. They're given to you. So 3x plus 12 is equal to 8x plus 18. This is the reason we know this. It was given to us. All right, my next statement says 12 is equal to 5x minus 18. Well, I got to look up here and see, what did I do to both sides in order to get from here to here? Well, I subtracted 3x from both sides. Because this became 0, 8 minus 3x became 5x. This is the subtraction property of equality. All right, so now I went from 12 equals 5x minus 18 to 30 equals 5x. So what did I do? Well, I just added 18 to both sides. That's the addition property of equality. These two are equivalent things. And if that is true, then I can add the same number to both sides. I'm adding 18 to both sides. Why do I do that? Because that drops off the 18 on this side. This becomes 0. All right, now I go from 30 equal 5x to 6 equal x. So what did I do to both sides? I divided both sides by 5. That's the division property of equality. I divided both sides by 5. 30 divided by 5 is 6. Now, I had 6 equal x, and I wanted to flip-flop it to x equals 6. What do you notice? Okay, which property up here? That's the symmetric property of equality. So yes, you're going to need to know what these properties are. Some of them should make sense to you, right? Let's take a look at your notes page. This one right here. They showed you an example, the algebraic steps, step by step, and the properties or the reasons given on why you can do these things. I'm going to zoom in a little bit. All right, some example exercises down below. It says complete each proof. Okay, and there are some empty boxes. It says given 4x plus 6 all over 2 is equal to 9. And we want to prove that x is equal to 3. First statement, where did it come from? Most of the time, that is given to us. We've got to start somewhere. All right, then they took 2 times both sides. And that must be missing here. If you notice, I have 2 times 9 and I have 2 out here. That's the multiplication property of equality. Okay, so now I've got 4x plus 6 equal to 18. What did I do there? Well, 2 times 9 is 18. 18 is an equivalent. So I just use substitution. My 2 divided by 2 canceled out for 1. Substitution, equivalent values. I just replaced 2 times 9 with 18. Now what am I doing to both sides? 4x plus 6 minus 6 equals 18 minus 6. Well, I'm subtracting 6 from both sides. So this is the subtraction property of equality. All right, now they want us to use substitution, and they want 4x equal to, well, 6 minus 6 is 0, so they eliminated that. 18 minus 6, I can replace that with 12. Okay, that's substitution, a replacement. Now it's dividing 4 by both sides. It's saying the division property of equality. So I have to divide both sides by 4. That's that empty box. So then I'm left with 4 divided by 4 is 1x. 12 divided by 4 is 3. X equal 3 by substitution, because I'm replacing 12 divided by 4 with 3. All right, let's do another example. Given 4x plus 8 equal to x plus 2, we want to prove that x is equal to negative 2. So we start with the given information. That's what we started with. Now let's see, what are they doing to both sides? They are subtracting x from both sides. Okay, right here, subtracting x. Okay, right there. That's the subtraction property of equality. Okay, then they filled in all of C for us because they substituted 4x minus x is the same as 3x plus 8 equal to 2. Now they want us to use the subtraction property of equality up here. So you know what? I'm going to subtract 8 from both sides. So I'm going to have 3x plus 8 minus 8 is equal to 2 minus 8. Now they want us to substitute equivalent values. Well, 8 minus 8 is just 0. I'm going to leave that off this left side. Now I need to substitute an equivalent value of 2 minus 8. That's negative 6. Now in step F, they're dividing both sides by 3. So this is the division property of equality. Now they want us to use substitution, so they want us to replace equivalent values. Well, 3 divided by 3 is 1x. Negative 6 divided by 3 is negative 2. Negative 2 is a replacement for this, so that's substitution. Right? Today in your homework, that's what you're going to be doing. You're going to be identifying properties. Okay, so if we take a look, you're going to identify the properties that each one of these represents. Then you're going to fill in some reasons. Okay, you are just doing page 25 on the yellow sheet, but there's also a Google worksheet for you to work on. Okay, if you get stuck and have questions, I've opened up a Google form, a Google Doc where you can submit your questions. I will be checking it regularly and will put my answers in red. Feel free to email me if you have any questions. Have a great day.